Hello class, in this video I'll be doing an application of linear programming that involves either minimizing or maximizing a given quantity. Let's begin. When I solve an application problem, I'm going to follow these 5 steps. 1. I'm going to identify the variables. 2. I'm going to create the objective function. 3. Create the constraints. 4. Graph the constraints and identify the corners. And that is going to be done on Desmus since these are word problems. And finally 5, identify the corner that will minimize or maximize the objective function. So let's take a look at an example. Go ahead and pause the video to read the problem. Welcome back. I will start by defining the variables. I'm going to highlight part of the second to last sentence here. And it states how many refrigerators should be shipped to each warehouse. So what I'm going to do is I'm going to let X equal the number of refrigerators shipped to warehouse A. And then I'm going to let Y equal the number of refrigerators shipped to warehouse B. Okay, next we want the objective function. So the goal is to minimize the costs. So let's highlight the sentence that deals with costs. So the problem states it costs $12 to ship a refrigerator to warehouse A and $10 to ship to warehouse B. So I'm going to let Z equal 12x plus 10y. And then we're going to let Z be the total cost to ship the refrigerators. Okay, so now that we have the variables and we have the objective function, we can now create our constraints. So let's take a look at the first sentence. It states a manufacturer of refrigerators must ship at least 100 refrigerators to its 2 West Coast warehouses. Well, the 2 West Coast warehouses are warehouse A and warehouse B, so I can write the first constraint as X plus Y is greater than or equal to 100. Okay, for our next constraint, each warehouse holds a maximum of 100 refrigerators. Warehouse A has 25 on hand. Okay. So we're going to have warehouse A, which we represent with an X. It holds a maximum of 100 refrigerators. However, they already have 25. So X has to be less than or equal to 100 minus 25, which implies that X is less than or equal to 75. Okay. Warehouse B has 20 on hand. So warehouse B is represented Y, So y is less than or equal to 100 minus the 20 that they already have on hand. So that means y has to be less than or equal to 80. Okay, and we have one more constraint. It says union rules require at least 300 workers to be hired. Shipping a refrigerator to warehouse A requires 4 workers, while shipping to warehouse B requires 2 workers. Okay, so that can be written as the following. 4x plus 2y is greater than or equal to 300. Okay, so now that we have all of our constraints here, we have the one in green, the one in blue, the one in pink, and the one in dark purple. I'm going to go into Decimus and graph all of those constraints. Okay, so as you'll notice, all of the constraints are already graphed in Decimus. However, we're given I have a blank, well not a blank, but I have a purple screen here. So what I'm going to do is I'm going to change the viewing window so that we can create and see the feasible region. So I'm going to go over here to the wrench, and we're going to let x go from 0 to, let's say, I don't know, 200. And I'm going to do the same thing for y. Okay, so we have a feasible region here, and you may notice the little shape, the little four-sided shape, that's the darkest shape of all the shaded regions. So what I'm going to do is I'm going to identify the corners now. The first corner is 3580. The next corner is 7580. Then we have 5050. And finally, 7525. So again, the feasible region is going to be the darkest shaded region that you see here. Okay, so now that I have all 4 corners, I'm going to go back into the notes. So we have the corners as the following. $75.25, $50.50, $75.80, and $35.80. Okay, so now I'm going to evaluate the objective function for each one of these corners. So for the first corner, that implies that z is equal to 12 times 75 plus 10 times 25, which is equal to 1150. And I'm going to complete the rest of the arithmetic now. Okay, so to minimize the cost, it looks like we're going to ship 50 to warehouse A and 50 to warehouse B. So I'm going to write that as a sentence now. A minimum cost of $1,100 is obtained by shipping 50 refrigerators to A and 50 refrigerators to B. And we are done.